Hello all, welcome back to the channel. This is Ganesh for Agnesoft. In this video, we will take a look at what is cloud computing, why do we need it, and what problems does it solve. Why did the organizations adopt cloud computing so quickly? This video also tries to introduce you to the pre-cloud era, that is how organizations build their own infrastructure before cloud computing existed. So get comfortable, scribble some notes, and let's get started. Before we discuss cloud computing, that is, what is cloud computing, let us try to understand why we need it and what is its significance. Not so long ago, organizations faced a much different landscape when setting up their IT infrastructure. It was a time when flexibility was limited, scalability came at a steep price, and agility was a concept yet to be realized. Organizations had to build, manage their IT infrastructure from ground up. Let us take a look at some of those challenges. Organizations had to invest heavily in physical servers, storage devices, and networking gear. These were housed in on premise data centers, which required significant space, power, and cooling. A small miscalculation in demand could lead to over provisioning, that is, wasting money on unused resources, or under provisioning, causing performance bottlenecks. Deploying IT infrastructure was a lengthy process. Procuring the hardware from vendors often took weeks or months. Setting up servers, networking equipment, and storage devices was a time consuming process. IT team configured systems manually, ensuring they worked together seamlessly. Rigorous testing was performed to ensure the stability of the applications before they went live. Once the infrastructure was operational, maintenance became a continuous responsibility. This included maintenance of hardware components, that is, replacing failing hard drives, power supplies, or any other components. Software updates for operating systems and applications were a tedious process. IT teams were also responsible for managing their BCDR, that is, business continuity and disaster recovery, by ensuring data is backed up and could be restored in case of a failure. Scaling on premise infrastructure was a daunting task. If a company wanted to expand its operations, it required purchasing more servers, storage, and networking gear. Conversely, if demand decreased, businesses were left with unused resources that still incurred maintenance cost. Scalability was neither cost effective nor quick, often leading to inefficiencies. Often, multinational corporations would need to set up data centers in multiple regions to support their global teams. This would significantly increase the cost and complexity. Organizations often spend so much time on resources and maintaining their IT infrastructure that they struggle to focus on innovation. Launching new applications or adopting to new emerging technologies require not only capital but also extensive planning and time. Alright, now let's try to understand how cloud computing resolved the previously observed challenges of the IT infrastructure. Cloud computing is a technology that provides on demand access to computing resources, such as servers, storage, databases, networking, software, and analytics. These resources are consumed over internet. Instead of buying, owning, and managing this physical hardware, organizations could now rent, scale these resources as needed, paying only for what they use. The major advantage of cloud computing is that it removed capex altogether. Capex or capital expenditure is incurred when purchasing this physical infrastructure such as servers, storage, or even setting up of the data center. Cloud offered a pay-as-you-go model, allowing businesses to scale resources instantly, access the data from anywhere in the world, and benefit from advanced security measures, all without the need of physical infrastructure. This now meant cloud computing was a game changer, allowing small startups to compete with large enterprises by giving them access to powerful IT resources at a fraction of cost. Let us now take a look at some of the key characteristics of cloud computing. Users could now provision computing resources without human intervention. Resources could now be accessible over internet using standard devices such as laptops, desktops, workstations. Multiple users share a pool of computing resources, ensuring cost efficiency. Resources could scale up or scale down dynamically based on demand. Usage is always monitored, controlled, and built transparently. Every organization has its own cloud computing strategy. This could be public cloud, private cloud, hybrid cloud, or multi cloud. In public cloud, an organization completely hosts all its services on one of the big hyperscalers. In a private cloud, a dedicated infrastructure or a data center is managed for a single organization. Hybrid cloud strategies mostly include both of combination of public and private clouds, allowing data and applications to be shared among them. Multi-cloud is a strategy where the services are from different cloud providers to optimize performance and cost. Now let us understand cloud computing service models, generally known as X as a service. So what is a service model? At a high level, service model defines the shared responsibilities between cloud providers and cloud users. These responsibilities define what type of service model the organization consumes. In an on-premise setup, all of the IT infrastructure, that is hardware, software, networking, is managed on-site by the organization. This involves high upfront capital expenditure for purchasing of hardware and software components. Scaling is only limited by the physical hardware. Traditional scaling requires purchasing and installing new equipment. However, this approach is fully customizable, but requires significant effort and expertise. The organization is responsible for all of the maintenance, updates, and security. A good example would be on-site data centers and private servers. In this approach, IaaS, the infrastructure is provided over virtualized computing resources such as server, storage, and networking over the internet. The cloud provider manages the hardware, organization manages the operating system, application, and the data. Here the cost is based on the usage, called as pay-as-you-go model for virtualized resources. This approach is highly scalable. Resources can be added, removed on demand. Even though highly customizable infrastructure, it requires significant technical expertise to configure them. Organization handles the operating system and application updates. The cloud provider handles the hardware maintenance. In PaaS, the cloud providers provide a platform for developers to build, test, and deploy applications without managing infrastructure. Cloud providers manage the hardware, the operating system, and the runtime, and the organization manages the application and the data. Similar to IaaS, here as well, we only pay for what we use. That is, pay-as-you-go model for platform services. Highly scalable, platform scales automatically based on application needs. However, this approach has limited customization and is focused on application development. Cloud provider handles the infrastructure and runtime maintenance, and the organization focuses only on application. SaaS provides a ready-to-use software application over the internet. No need to install or maintain the software. Fully managed by the cloud provider, including the hardware, operating system, and the application. This is a subscription-based pricing model or an OpEx model. It automatically scales, no user intervention is required. Minimal or no customization is possible. Users work within the constraints of the software. The cloud provider handles all of the maintenance, updates, and security. So, who should use what service model and what could be the use cases behind it? Banks and other financial institutions, government agencies, and organizations with legacy system usually prefer on-premise infrastructure for data security. E-commerce websites, startup needing scalable infrastructure prefer IaaS. Software development companies building custom applications usually prefer platform as a service. And finally, small businesses using tools like CRM, email consume these services as SaaS model. The key drivers for cloud adoption were cost efficiency, eliminating the capital expenditure for hardware, quickly adapting to changing workloads, bringing in scaling up and scaling down. Resources were available worldwide, providing a global reach. Data backup, disaster recovery, and high availability were baked in. Advanced security tools and compliances were provided for data security and applications. This enabled the common use cases for storage and backup, web hosting. Cloud platforms also offered pre-built tools for AI and ML, automating development and software development lifecycle by enabling deployment pipelines. The key takeaway from this video is that we've understood the challenges of on-premise infrastructure to the limitless possibilities of the cloud. IT has come a long way. Cloud isn't just a technology, it's a game changer for a lot of startups and AI-enabled workloads. So, in this exciting journey, join me and understand and let's dive into the world of AWS, Azure, Google Cloud, and rest of the other cloud providers, and let's try to get into some of those concepts and understand them deep dive. Thank you and see you in the next video.